Hello, AP Environmental Science. This unit is about land, public and private, the land use concepts and how we classify them, and land management practices. When it comes to harvesting our resources, it's not always about farming and providing crops and waterways. Sometimes let's talk about the abiotic stuff here, mining. Mining produces all of our necessary minerals and resources that come out of the ground, and we need a lot of these minerals and mining resources to exist. Oftentimes when students think about mining, they think about, silver, diamonds, gold, jewelry, granite countertops. But essentially, mining produces all the materials that we need that are abiotic in fashion. Pretty much every part of the construction material, sheetrock, tile flooring, things that we use to build our house, any electrical components, copper, things that build pots and pans, metals, all these day-to-day things, and electronics. They're filled with mineral and mining resources inside of them. So this has become our way of life. We're no longer just mining for golds, but now we mine for door handles, doorknobs, car parts, cell phone batteries, and so much more. Unfortunately, the distribution of mineral resources on Earth has not only environmental consequences, but social as well. The tectonic cycle, the rock cycle, and soil formation and erosion all influence the distribution of rocks and minerals on the planet. These resources, along with fossil fuels, exist in very finite quantities, but they're all vital to our modern human life. And so in this part, we're going to discuss how some important like non-fuel mineral resources and how humans obtain them, how that influences valuability, abundancy, and some areas of human living. As we saw in the Earth Resources unit, Earth cooled at different vertical zones. And so heavy elements sank towards the core and lighter elements rose towards the crust. So crustal abundance is the average concentration of an element in Earth's actual crust. If you're looking at this diagram right here on the next page, you will see that there are 4 elements: oxygen, silicon, aluminum, and iron, and they constitute over 88% of all the Earth's crust. However, the chemical composition of the crust is highly variable from one location to another. Environmental scientists and geologists study the distribution of these types of mineral resources around the planet, really kind of in order to not only locate them, but also to manage their extraction. Ores are concentrated accumulation of these minerals from which has some sort of economic value and that we can extract the mineral and the resource from. Ores are typically characterized by the presence of valuable metals, by accumulation of other minerals too, like sand and silt, and they can be considered ores. Metals are elements with properties that allow them to conduct electricity and heat energy to perform, important functions. Copper, nickel, and aluminum are common examples of metals, and they exist in varying concentrations of rock, and they're usually associated with elements like sulfur, oxygen, and silicon. So some metals, like gold, they exist naturally in their pure form, while others have to be mined and completely taken apart in order to pull that one element out of it. The global supply of mineral resources is difficult to quantify. Because private companies hold the rights to extract certain mineral resources, information about their extraction and quantities and resources is not always available to the public. They're pretty private about this. So, publicly known estimates of how much a particular resource is being available is what we would call a reserve. And the reserve is the known quantity of the resource that we can economically recover at a certain time. The reserve is not always an accurate estimate because some of these minerals are protected by private companies. But basically, the element composition of the Earth's crust, you can see here, oxygen is the most abundant element in the crust. Silicon, aluminum, and iron are the next 3 most abundant elements here. And so ores and minerals, exists in a multiple combination of these things, and oftentimes we have to extract out like magnesium and iron in order to get at something else. This table lists the estimated number of years of the remaining supply of some of the most important and abundant or not abundant metal resources commonly used in the United States and among developed nations. Assuming that there's no rate of change, these numbers will stay pretty accurate. Some important metals like tantalum have never existed in the United States, and the United States has used up all of its reserves in some of its other metals, like nickel, for example. And we must now import these metals from other countries. How we mine for these minerals, there are lots of different techniques. And mining can be actually at the surface, or we can go below the surface. So mineral resources are extracted from earth by mining the ore and then separating that ore into out its mineral, element, and rock components. Whatever we're seeking, whatever element we're seeking after. So in the next illustration, in this illustration too, you can see that there are multiple types of mining that can take place in just one type of area. But surface mining is done in a strip mining, open pit mining, mountaintop removal, or what we call placer mining. A variety of surface mining techniques can be used to remove minerals and ores and deposits that are close to Earth's surface. Strip mining, or the removal of strips of soil and rock to expose the underlying ore, is used when the ore is relatively close to Earth's surface and it runs parallel to it, which is often the case for deposits of sediment minerals like coal and sands. In these situations, miners remove a large volume of material and then they extract the resource and return the unwanted waste back to that actual area. So mining soils, or what we call tailings, to a hole created during the mining process create this open surface mining situation. And a variety of strategies can be used to restore these areas that we've affected due to this type of mining and conditions. And so oftentimes this can be one of the easier ones to recover. Open pit mining, however, is a mining technique that creates this large visible pit and hole in the ground. And it's used when the resources are close to the Earth's surface but extend beneath the Earth's surface horizontally and vertically. So traditionally copper mines were used, open pit mines, and then one of the largest open pit mines in the world is the the Canyon Mine near Salt Lake City, Utah, and that is actually a copper mine that is 2.7 miles across. In mountaintop removal, miners remove the entire top of the mountain with explosives, and then large earth-moving equipment comes in and basically removes and extracts the resources and deposits and tailings in the lower elevation regions that are also nearby. So, where there's mountains, there are rivers and streams, right? And so this has been one of the higher environmental impact types of mining. Placer mining is the process of looking for metals and precious stones in river sediments. So miners use the river and the actual water in the river itself to separate heavier items like diamonds and tantalum and gold from the lighter items like sand and mud. And so prospectors in California in the gold rush in the 1800s, those are what we call placer miners. And they basically, this technique is still used today. If you've ever watched Prospectors, which is a series of shows on TV, on National Geographic, and where they use this type of water separation process to find gold and gems and precious metals that are in the river system. Subsurface mining is the one that they make movies about. When a desired resource is more than 100 meters or 328 feet below the Earth's surface, miners must turn to subsurface mining, which is basically a mining that occurs below the Earth's surface, and it's typically a subsurface mine because of a horizontal tunnel that they dig on one side of the mountain, and it has these really cute features as far as like an elevator type of system. But anyway, from this horizontal tunnel, vertical shifts can be drilled and extracted, and they make elevators and create this whole underground, structure. And they basically use all of this stuff to bring miners down all the way to the Earth's surface, to the deepest part of the Earth that we can go, about 2.5 miles deep. And that's usually where we find things like coal and now diamonds and gold. And there's a lot of other types of resources that are removed by subsurface mining. So here we have just a general diagram about different mining in general. You can see where there's different types of shaft mines that are created. They drill horizontally into the side of a mountain, and they create all of these slopes. So like if they know that the resource is in a certain area right here, they can drill down and just create this whole area to be extracted. And then oftentimes when they remove this whole top of the mountain like this, it's because there's some sort of bedrock that's right here that is just essentially easier to get to if they just remove the top of the mountain. Because remember, when plate tectonics are formed, mountains are oftentimes areas that have been pushed up like this, like where the area is just being like pushed up. And so we see a resource, like in this diagram, a coral bed, that's right here. And so it's just easier to come in and like chop off the mountain than it is to like drill in a certain way. But anyway, there's lots of surface mining methods. They all have fancy names, and you kind of have to know the basic ones. Here is another type of mining diagram that shows these vertical hoist types of systems where there's a massive ore deposit that's underground. It's not always at a mountaintop. And then an open pit mining right here where we've just removed a certain surface and put the tailings out somewhere, and now we're at the actual ore. A lot of times you see these little tiny little buildings, these mining outcrops right here, where there's little buildings that are over the shaft that's now required by government law. But anyhow, like you can see a whole mining industry, there's little tiny buildings up top where all of the activity is underground. And there's lots and lots and lots of different ways that they do this now with modern technology. But at the end of the day, we're still drilling underground and sending people down. The extraction of mineral resources from Earth's crust has a variety of environmental impacts, even on soil, water, biodiversity, and lots of other areas. In addition, mineral resource extractions can have human health consequences that affect not only the miners directly, but other individuals who live near the area. They can also be affected by the mining process. So as you can see in this table, all forms of mining affect the environment. Mining almost always requires the construction of roads, which can result in soil erosion, damage to waterways, and habitat fragmentation. In addition, all types of mining produces tailings, the residual stuff that's left behind after the desired material is, been removed. And some of these tailings, they pretty much contaminate land, and they actually add a lot of acids and metals back into the soil layer. In mountaintop removal, placer mining, a lot of environmental impacts come from damaging nearby streams. And so mining safety and legislation has become increasingly more important here. The Surface Mining Control and Reclamation Act of 1977 regulates surface mining of coal and the surrounding effects of the subsurface area. And this act mandates that the land be minimally disturbed during the mining process and reclamation after mining has been halted. So along with that Surface Mining Control and Reclamation Act, U.S. legislation that does also to some extent also protect these issues would also include, again, the Clean Air Act, the Clean Water Act, and the Superfund Act.